Welcome to It Fillet, a series of SolidWorks video tutorials presented by the DiMonte Group. In It Fillet, we take a look at the fillet tool in SolidWorks and ways we can add problematic and tricky fillets to our models. My name's Andrew Lowe. I'm an industrial designer with the DiMonte Group. In this installment, we're actually going to take a look at situations where the fillet tool doesn't get the results that we need, and we need to use the surface tools to build fillets. So some shapes can't be created with fillets. They require blends to look right. The aluminum group chair, designed by Charles and Ray Eames, is an example of this. This base has a very smooth, organic shape, and the surfaces in this cannot be created with the fillet tool, so we will need to manually build this geometry. So let's get into SolidWorks here. So I've started the one leg of the chair, and note that I've only modeled half of it because I can mirror it at the end. I've used a boundary surface. I could have also used a surface loft to build the foot of the chair and the main leg of the chair. And right now I'm concerned about building this transition between the two. So it's not really a fillet, it's a type of blend. So we're going to have to build it face by face using the surface tools. The first thing I do is create a surface extrude from the symmetry plane. The reason I do this is that I need to ensure that the surfaces I build are tangent to this surface here, so that way when I mirror the geometry I don't have a hump or a dip in the part. So the sketch I've used here is a spline between this edge and this edge, and a second spline between this edge and this edge. I've applied the equal curvature relation because I'm aiming for a C2 or equal curvature relation. Note that the curvature is changing. It's not a standard fillet shape that would have constant radius along its length. The radius is starting at 0 here, the same as the straight line, and it's changing along the length of the spline, tapering down to 0 here, the same as this straight line. So I've now outlined the shape of the blend, and now I need to blend the faces together. However, I have one face here versus three faces here on the leg. So what I'm going to do is use a split line. Here I've created a plane. If we take a look at this plane, I've made it through this point and parallel to the right plane. And here I can use that plane with a split line. Before we've used sketches to split geometry, but here I'm using the intersect option, and now I've taken three faces, and also I've taken this one face, and I now have three faces. The reason being is I want to try and blend between an equal number of edges. The blend will work out better if I do this. So I'm going to create the first portion of the blend with a boundary surface. Here I have this edge and this edge. First, combining the edge from the chair leg into the edge of the foot. Note that I required a second sketch here, so if we take a look at this sketch is on that helper plane here. And once again I have some splines, and I've added the equal curvature relation. If I show curvature, you can see that the curvature starts at 0, tapers up, and then comes back at 0 again. So this is not an arc base shape. This is a spline-based shape, but now this creates the fourth edge of this boundary surface. So because I'm going for a curvature continuous connection, note that I've used the curvature option and not the tangency option. Think of curvature as tangency's bigger brother. It creates an even smoother connection. If you add tangency and you see this error message, you can just click OK. It means that the faces have a microscopic difference in angle in them, and that for all intents and purposes it's not going to affect our surface. So here I have edge of curvature, and I have tangency applied to the reference surface here. This is so that way when this is mirrored there's no dip or hump. One thing we may need to do is increase the tangent influence. With the tangent influence at 0, we can use what's called the curvature combs to evaluate the quality of the surface. And here we see that the radius is changing rapidly here as it approaches the symmetry plane. What happens when we increase the tangent influence to 100 is that it smooths that out and eliminates that sharp increase in curvature, creating a better looking surface. So the next thing I will do is create the bottom of the blend. I have that sketch creating that fourth edge, that rail, to help guide the surface. And here I'm doing the same thing, curvature to face between the two edges in blue, and tangency applied to the reference surface. Here I've had to also increase the tangent influence to 100 from 0. We see that the uneven curvature here with it at 0, increasing to 100 limits that effect. So I now have a final outline for my blend, and I'm going to use surface knit here. I may be able to use boundary surface, so let's take a look at what that looks like. So let's go between these two edges and these two edges, and now I'm going to apply curvature, ignoring the error message to all of the faces. And here we see the geometries flipping on itself, so I may need to increase the tangent influence to 100. So this is a pretty good result, but if I zoom in, I can actually see a little ripple here at the bottom. So sometimes boundary surface doesn't produce the best results because it uses the math of the surrounding geometry. So maybe I do need to add curvature on these other edges. And by actually adding curvature there, looks like I've tamed that geometry a little bit. But I introduced this big ripple here. So sometimes when creating this geometry, I'm just going to complete the blend with a surface fill. What surface fill is doing is actually creating a bigger four-sided surface. You can see the shape of it here in this yellow grid preview, and it's fitting it to the profile. So I've set curvature to all edges, and that creates a much better looking blend. So let's mirror the foot, turn off our edges, and just examine the quality of the surface we built. So we see we have a really nice smooth connection between the leg and the foot of this chair base. And I built geometry that I wouldn't be able to use or build using the standard fillet tool, because we kind of have this filleted shape, this flat shape, and this bottom filleted shape transitioning into a cylinder here. So to recap, when modeling this kind of smooth organic geometry, sometimes the fillet tool doesn't give the best results. So when modeling these advanced blends, the starting point could be surfaces or solids, but I need to use delete face if I'm using solids to turn them into surface bodies, because I will be using surface features to build the blends. I've connected the shapes with some splines. Equal curvature relation was added to both ends, and then I created an extruded surface to ensure tangency along the symmetry plane. I'm modeling the transition, making sure I have an equal number of edges that I'm blending between. I'm using the equal curvature relation on the two edges in blue here to ensure a smooth connection, and tangency to this purple face to ensure there's no hump or dip along the symmetry plane when mirrored. When the blend region is outlined, I've used the surface fill tool to complete the blend. So thanks for watching this installment of Will It Fillet. Please follow the DiMonte group on LinkedIn, where we'll be announcing new videos.